In this video, before we go into example problems, we will have a quick look at how to derive the identities, which are product identities, and how these can be converted into sum identities. Okay, so we are already familiar with these four identities. Now we're going to introduce this new identity, which is sin A cos B is equal to half of sin A plus B plus sin A minus B. So let's take the first two identities and let's add them up. So let's take sin A plus B plus sin A minus B. So to add them up, let's first replace A plus sin A plus B with the formula. So that is sin A cos B plus cos A sin B plus sin A minus B is sin A cos B minus cos A sin B. Now these two terms will disappear, plus and minus, and these two terms are the same, so this becomes 2 times sin A cos B. So we can rewrite this by taking the 2 to the other side. Sin A cos B is equal to 1 by 2 times sin A plus B plus sin A minus B. In a similar manner, we can derive all these identities, which is cos A sin B is equal to half of sin A plus B minus sin A minus B. Cos A cos B is equal to half of cos A plus B plus cos A minus B. Sin A sin B is equal to half of cos A minus B minus cos A plus B. Similarly, we can also derive sin C plus sin D is equal to 2 times of sin C plus D by 2 cos C minus D by 2. To prove this, let's take the first formula here and let's put A is equal to C plus D by 2 and B is equal to C minus D by 2. And let's also move the 2 to the opposite side. So this becomes 2 times sin, our A is C plus D by 2 and multiplied by cos, B is C minus D by 2. This is equal to, let's put the formula here now, which is sin A plus B, and our A is C plus D by 2 plus, and our B is C minus D by 2 plus sin, again A minus B, and A is C plus D by 2 minus our D is C minus D by 2. Simplifying this, this becomes sin C plus D plus C minus D divided by 2 plus sin C plus D here and minus C, minus into minus plus D divided by 2. Further simplifying this, the 2 D's will disappear here and the 2 C's will disappear here. So this becomes sin 2C by 2 plus, and this is sin 2D by 2, sin 2D by 2, which is nothing but sin C plus sin D, which is the proof of our formula here. Similarly, we can prove sin C minus sin D is equal to 2 times cos C plus D by 2 sin C minus D by 2. To prove this, you would use this formula cos A cos B, and you can also prove cos C plus cos D is equal to
2 times cos c plus d by 2, cos c minus d by 2, and cos c minus cos d is equal to 2 times sine c plus d by 2, sine d minus c by 2. Identity 3.15. Prove that sine 60 minus a, sine 60 plus a is equal to 1 by 4 sine 3a. The formula that we would be using here are sine a sine b is equal to 1 by 2 cos a minus b minus cos a plus b. And the second formula that we would use is cos 2a is equal to 1 minus 2 sine squared a. And the third that we would use is sine 3a is equal to 3 sine a minus 4 sine cube a. So, to solve, let's rearrange the given expression as sine 60 minus a, sine 60 plus a, and sine a. Now, the first two terms is in the form sine a, sine b. So, let's consider our a here to be equal to 60 degrees plus a, and our b as 60 degrees minus a. Therefore, substituting in this formula, you would get half cos, this is a big bracket here, a minus b. Our a is 60 plus a and b is 60 minus a. So, it's 60 plus a minus 60 degrees plus a. So, 60 and 60 will disappear here. Then it's minus cos a plus b. So, again adding these two, 60 degrees plus a plus 60 degrees minus a. The a and a will disappear. So, you will have half of cos 2a minus cos 120 degrees. So, we have that for the first two terms into sine a. Next, let's replace cos 2a using this formula. So, here this expression will become half of 1 minus 2 sine squared a, and our minus cos 120 will be equal to minus sine 30, which will be plus 1 by 2. So, this is a plus 1 by 2. This will be equal to this plus 1 by 2 here, and you're left with the sine a here. So, into sine a. So, this further simplifying, you would get, keeping the half outside and moving the sine a in, you would get 1 into sine a will be sine a minus 2 times sine cube a, sine a into sine squared a will be sine cube a, plus half of sine a. So, here we have a sine a plus a half of sine a. So, this is equal to half. Sine a plus half of sine a will become 3 by 2 sine a minus 2 times sine cube a within brackets. Now, if I multiply and divide by 1 by 2, by 2, so it's 1 by 2 here. Then if I multiply within bracket by 2, so it will be 2 times 3 by 2 sine a minus 2 times sine cube a, which will be 1 by 4 3 sine a minus 4 sine cube a. Now, here you can see that 3 sine a minus 4 sine cube a is nothing but sine 3a. So, this is equal to 1 by 4 sine 3a. Hence, the proof of this problem. And similarly, we can also prove that cos 60 minus a, cos 60 plus a is equal to 1 by 4 cos 3a, and tan 60 minus a, tan 60 plus a is equal to tan 3a. Example 3.33. Express each of the following product as a sum or difference. First question is sine 40 and cos 30. So, we know that 2 sine A cos B is equal to sine A plus B plus sine A minus B. So, let's take here our A as 40 and our B as 30 and replace in this formula. So, what we will get is sine 40 degrees, 2 times sine 40 into cos 30 degree will be equal to sine 40 plus 30 plus sine 40 minus 30, which is sine 70 degrees plus sine 10 degrees. Therefore, our sine 40 degrees cos 30 degrees will be equal to 1 by 2 times sine 70 degrees plus sine 10 degrees. Now for the second part of the question, which is cos 110 sine 55 degrees. So, we know that 2 cos A sine B is equal to sine A plus B minus sine A minus B. So, let's take our A to be 110 and our B to be 55 and let's substitute in this formula. So, 2 times cos 110 degrees sine 55 degrees will be equal to, according to the formula, sine 110 plus 55 minus sine 110 minus 55 degrees. So, which is nothing but sine 165 degrees minus sine 55 degrees. Therefore, our cos 110 degrees sine 55 degrees will be equal to, taking the 2 to the other side, 1 by 2 times sine 165 degrees minus sine 55 degrees. Now for the third part of the question, sine x by 2 cos 3x by 2. We know that 2 sine A cos B is equal to sine A plus B plus sine A minus B. So let's take our A to be x by 2 and B to be 3x by 2. So substituting, we get 2 times of sine x by 2 into cos 3x by 2 is equal to sine of x by 2 plus 3x by 2 plus sine of x by 2 minus 3x by 2. So this, for the simplifying, this becomes sine of 4x by 2 would be 2x and plus this will be sine of x minus would be minus 2x divided by 2. So which is equal to sine 2x minus sine x. Therefore, our sine x by 2 cos 3x by 2 is equal to 1 by 2 sine 2x minus sine x. Example 3.34. Express each of the following sum or difference as a product. So we have the first question, which is sine 50 plus sine 20 degrees. And we know that sine C plus sine D is equal to 2 times sine C plus D by 2 cos C minus D by 2. So let's take our C to be 50 and our D to be 20. So we have sine 50 degrees plus sine 20 degrees is equal to 2 times sine 50 plus 20 divided by 2 into cos 50 minus 20 divided by 2, which is 2 times sine 70 by 2 would be 35 degrees into cos 30 by 2 would be 15 degrees. Question number 2. Cos 6 theta plus cos 2 theta. Again, we know that cos c plus cos d is equal to 2 times cos c plus d by 2 into cos c minus d by 2. So let's take our c to be 6 theta and our d to be 2 theta. So here this becomes cos 6 theta plus cos 2 theta is equal to 2 times cos 6 theta plus 2 theta divided by 2 into cos 6 theta minus 2 theta divided by 2. So that's equal to 2 times cos 8 theta by 2 would be 4 theta and 4 theta by 2 would be 2 theta into cos 2 theta. That's the answer. Question number 3. To express this as a product, which is cos 3x by 2 minus cos 9x by 2. So we know cos c minus cos d is equal to 2 times sine c plus d by 2 into sine d minus c by 2. So let's take our c as 3x by 2 and our d as 9x by 2. So we have cos 3x by 2 minus cos 9x by 2 is equal to 2 times sine 3x by 2 plus 9x by 2, the whole thing divided by 2 into sine d is 9x by 2 minus 3x by 2, the whole thing divided by 2. So this is equal to 12 by 2 will be 6x. So 2 times sine 6x by 2 would be 3x into sine, here we have 6x by 2 which would be 3. So that would be 3x by 2. Example 3.35. Find the value of sine 34 degrees plus cos 64 degrees minus cos 4 degrees. Let's use this formula on the last two expressions here and let's keep sine 34 as it is. So our sine 34 degrees plus cos 64 degrees minus cos 4 degrees will now become sine 34 degrees, we keep that as it is, plus our cos 64 minus cos 4 degree. Let's substitute this formula, which is 2 times sine 64 plus 4 will be 68 by 2 is 34 degrees into d minus c. So it's 4 minus 64, it will be sine minus 60 by 2, so that will be minus 30 degrees. So we can rewrite this as sine 34 degrees. Sine minus 30 will become minus sine 30, so this will be a minus here, 2 times sine 34 degrees, and sine 30 degree is 1 by 2. So 2 and 2 will become cancelled, so this becomes sine 34 degrees minus sine 34 degrees, which is equal to 0. Example 3.36. Show that cos 36 degrees, cos 72 degrees, cos 108 degrees, cos 144 degrees is equal to 1 by 16. So let's take the left hand side here. Left hand side is equal to cos 36 degrees, cos 72 degrees, cos 108 degrees, cos 144 degrees. Okay, let's rewrite the second expression as cos 90 minus 18 degrees and the third expression as cos 90 plus 18 degrees and the last expression as cos 180 minus 36 degrees. All of these are in degrees. Okay, so we leave the 36 as it is, cos 36. This we know is sine 18 degrees, and this is also sine 18 degrees, and this cos 36 degrees. So this is nothing but sine squared 18 degrees into cos squared 36 degrees. So we know that sine 18 degree, which we have seen in the previous chapter example problem. So sine 18 is root 5 minus 1 divided by 4, the whole squared, and cos 36 degrees is root 5 plus 1 divided by 4, the whole squared, which is, simplifying, you will get the answer as 1 by 16. That's equal to RHS. Hence the proof. Example 3.37. Simplify sine 75 minus sine 15 degrees divided by cos 75 plus cos 15 degrees. The formulae that we would be using here are these two formulae. So our left hand side, or the expression that needs to be simplified, the sine 75 degrees minus sine 15 degrees divided by cos 75 degrees plus cos 15 degrees will be written as, the numerator is 2 times sine c minus sine d is 2 times cos c plus d by 2, and sine c minus d by 2. So 2 times cos c plus d would be 75 plus 15, which is 90, divided by 2 will be 45 degrees, into sine c minus d, 75 minus 15 will be 60, divided by 2 will be 30 degrees, divided by cos 75 plus cos 15 degrees. We'll be using this formula here. So it's 2 times cos c plus d again divided by 2, so that's 45 degrees, and cos c minus d by 2, so that would be cos 30 degrees. So these two expressions will disappear and the 2 will disappear. So you're left with tan 30 degrees, which is equal to 1 by root 3. Show that cos 10, cos 30, cos 50, cos 70 is equal to 3 by 16. The identity that we'll be using is cos 60 minus a into cos 60 plus a is equal to 1 by 4 cos 3a. So let's take the left hand side, which is equal to cos 10, cos 30, cos 50, cos 70 degrees. Okay, so let's rewrite this. Let's take the cos 30 degrees separately, and let's rewrite this as cos 10 degrees, cos 50 degrees, and cos 70 degrees. Now you can further simplify. Cos 30 degrees nothing but root 3 by 2, and let's rewrite our cos 50 as cos 60 minus 10 degrees, and let's keep the cos 10 degrees as it is, and the cos 70 would be cos 60 degrees plus 10 degrees. Now this is in the expression cos 60 minus a, cos 60 plus a, where a is equal to 10 degrees. So this can be rewritten as root 3 by 2 into 1 by 4 cos 3 times 10 degrees. So which is equal to root 3 by 2 into 1 by 4 cos 30 degrees, which is root 3 by 2 into 1 by 4 into root 3 by 2. Further simplifying this, you get 3 by 16, which is equal to the right hand side, hence the proof.
Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.